The universe is vast, silent, and filled with secrets that would make your blood run cold. Picture this: the endless void of space, where light itself can vanish without a trace, where forces so powerful they bend reality lurk in the shadows. Out there, beyond the safety of our blue planet, exist horrors beyond comprehension, phenomena so terrifying they defy belief, and the scariest part, most of us have no idea they're even out there. Imagine drifting through the cosmos, surrounded by utter darkness, when suddenly something shifts, a soundless ripple in the fabric of space, an invisible force pulling at the very edges of your ship. No screams, no warning, just the chilling realization that you're not alone. The universe isn't just empty, it's alive with nightmares we've only begun to understand. From black holes that trap light itself to rogue planets wandering without a star, the cosmos is a gallery of horrors waiting to be uncovered. Today, we're peeling back the curtain on the 25 most terrifying things in space you never knew existed. These aren't just distant curiosities, they're real, lurking in the infinite expanse, reminders of how small and fragile we truly are. Some defy physics, others seem almost supernatural, and a few might make you question whether we should ever leave Earth at all. So buckle up. By the end of this journey, you'll never look at the night sky the same way again. Rogue black holes are the silent predators of the cosmos, invisible, unstoppable, and utterly ruthless. Unlike the black holes anchored at the centers of galaxies, these nomadic horrors drift through space without warning, swallowing anything unlucky enough to cross their path. Picture a collapsed star, its gravity so intense that not even light can escape, now untethered from its birthplace and wandering the galaxy like a cosmic phantom. These monsters form when massive stars die in violent supernovae, their cores collapsing into singularities so dense they warp the fabric of space itself. What makes them truly terrifying? They could be anywhere. Black holes don't glow or emit light, they lurk in the darkness, detectable only by the way they bend the light of stars behind them or rip apart nearby matter. And here's the chilling part: one could be barreling toward our solar system right now, and we might not know until it's too late. Imagine the slow, inevitable approach of a rogue black hole. At first, the outer planets would shudder, their orbits twisting unnaturally. Then, as it crept closer, entire worlds would stretch and distort, their matter spiraling into an inescapable void. The sun itself wouldn't stand a chance. Even if we spotted one decades in advance, there's nothing we could do. No force, no technology, no desperate escape plan could save us from being pulled apart atom by atom. Scientists estimate there could be millions of these unseen killers drifting through the Milky Way, each one a testament to the universe's indifference. The scariest thought: we've only just begun to find them, and every new discovery is a reminder space isn't just empty, it's hiding nightmares we've yet to uncover. Gamma-ray bursts are the universe's ultimate fireworks, spectacular, violent, and deadly beyond imagination. In just a few seconds, a single burst can unleash more energy than our sun will produce over its entire 10 billion-year lifetime. These aren't just distant curiosities, they're apocalyptic events capable of sterilizing entire sections of a galaxy in the blink of an eye. The mechanics behind them are just as terrifying as their power. Most gamma-ray bursts occur when massive stars, dozens of times heavier than our sun, collapse into black holes in hyperviolent supernova. As the dying star's core implodes, twin jets of radiation hotter than anything else in the universe scream outward at nearly the speed of light. If one of those jets happens to be pointing at a nearby planet, the results are catastrophic. The high-energy radiation would strip away the ozone layer in moments, exposing all life to lethal ultraviolet radiation from its own sun. The sky would literally cook the surface, triggering mass extinctions in hours. We know this isn't just theoretical. Earth has already felt their sting. In 2004, a gamma ray burst from a dying star 50,000 light-years away, slammed into our upper atmosphere with enough force to briefly ionize it, disrupting radio communications worldwide. If that burst had originated within just a few thousand light-years, the damage would have been irreversible. The frightening reality is that we'd have almost no warning. Light and gamma rays travel at the same speed, meaning we wouldn't see the burst coming until it was already here. By the time astronomers spotted the flash, the lethal radiation would already be bathing our planet. And with current technology, there's absolutely nothing we could do to stop it. Even more unsettling, statistically, a gamma ray burst capable of wiping out life on Earth should happen somewhere in our galaxy every few million years. Given that the universe is 14 billion years old, it's likely happened before and could happen again. The cosmos doesn't care about our existence. It simply obeys the cold, unfeeling laws of physics, occasionally reminding us just how fragile we really are. Vacuum decay isn't just a cosmic horror. It's the ultimate existential reset button, a phenomenon so catastrophic it could erase the universe as we know it in an instant. Picture the fabric of reality as a fragile sheet of ice stretched thin over a bottomless abyss. Right now, we're skating safely on its surface, unaware that beneath us, the ice might not be as stable as it seems. This is the nightmare scenario physicists call quantum vacuum instability, a glitch in the very code of the universe that could rewrite physics itself. At the heart of this terror lies a chilling idea. What if our universe isn't in its true, most stable state? Imagine a valley surrounded by towering mountains where our universe sits comfortably at the lowest point, or so we think. But somewhere beyond those peaks, there might be an even deeper valley, a state of existence where the laws of physics are fundamentally different. All it would take is a single quantum fluctuation, a tiny nudge to send reality tumbling over the edge. Once that happens, a bubble of true vacuum would form, expanding at the speed of light in all directions. Inside this bubble, atoms would unravel, forces would cease to function, and the very building blocks of matter would reconfigure into something unrecognizable. It's like a cosmic domino effect. Once the first tile falls, there's no stopping it. The wave of destruction wouldn't just annihilate planets or stars, it would rewrite the rules of existence itself, leaving no trace of life, light, or even time as we understand it. The most unsettling part, we wouldn't see it coming. By the time the bubble reached us, the edge of oblivion would arrive at the same moment as the light, warning us of its approach. 1 second, the universe would be normal. The next, everything, including you, would simply cease in a way beyond human comprehension. And here's the real kicker: this isn't science fiction. The math checks out. The Higgs field, which gives particles their mass, might not be in its absolute lowest energy state. If it's metastable, stable for now but not forever, then vacuum decay isn't just possible. It's inevitable. Some theories suggest it could happen tomorrow, or it might take trillions of years, but the dice are rolling every moment, and we're gambling with a universe that might not be as permanent as it seems. The cosmos doesn't owe us safety, it doesn't owe us stability, and lurking in the equations of quantum physics is a reminder that even the laws of reality might only be temporary. Vacuum decay is the ultimate silent threat, a whisper in the dark, waiting to rewrite everything. Deep in the cosmic shadows, hidden behind the thick veil of stars and dust in our own Milky Way, something monstrous is pulling entire galaxies toward it at 14 million miles per hour. Scientists call it the Great Attractor, a gravitational mystery so powerful it bends the motion of hundreds of thousands of galaxies, including our own. This isn't just a dense cluster of matter, it's a cosmic vortex so immense that it defies conventional explanation. The strangest part, we can't even see it directly. Our view is blocked by what astronomers call the zone of avoidance, a region of the sky obscured by the Milky Way's own gas, dust, and stars. It's like staring into a dense fog, knowing something colossal lurks just beyond sight. The gravitational effects are undeniable. Galaxies across our local supercluster are streaming toward this invisible behemoth as if caught in some unthinkable current. So what could possibly exert such a pull? One leading theory suggests a concentration of dark matter, an unseen megastructure with a mass equivalent to tens of thousands of Milky Ways. Dark matter doesn't emit light or interact with electromagnetic forces, making it utterly invisible to telescopes, but its gravitational grip is undeniable, warping space-time on a scale we can barely comprehend. Other researchers propose that the Great Attractor might be the heart of an enormous supercluster, a nexus where galaxies collide and merge in a slow-motion dance spanning billions of years. If we could peer through the zone of avoidance, the sight might be both awe-inspiring and terrifying. Simulations show galaxies stretched into vast filaments, converging like rivers into an unseen ocean. Even our Milky Way is caught in the flow, destined to eventually join this cosmic migration, though not for hundreds of millions of years. But here's the chilling question: what if the Great Attractor isn't the final destination? Some evidence suggests an even larger force might be at work, something beyond our current understanding, pulling the Great Attractor itself toward an unfathomably massive structure called the Shapley supercluster. It's a cosmic matryoshka doll of gravitational mysteries, each layer more puzzling than the last. We're left with an unsettling truth. Despite all our technology, despite centuries of observation, the universe still holds forces so vast they move galaxies like pawns on a chessboard, and we're only just beginning to understand the game. The Great Attractor isn't just a curiosity. It's a humbling reminder that even in our own cosmic backyard, the universe still has secrets that defy explanation. Among the countless horrors lurking in the cosmos, few are as deceptive as so-called zombie stars, stellar corpses that refuse to stay dead. These aren't your typical white dwarfs quietly fading into obscurity. No, these are the ones that claw their way back to life by draining the very essence of neighboring stars in a cosmic act of vampirism. Imagine a dense, Earth-sized ember, the burnt-out core of a long-dead sun, drifting too close to a living star. Slowly, mercilessly, it begins siphoning away its companion's hydrogen, growing heavier with stolen fuel until catastrophe. This is the origin of a Type Ia supernova, one of the most violent explosions in the universe. With no warning, the white dwarf crosses a critical threshold, its stolen mass reigniting runaway nuclear fusion in an instant. The resulting detonation outshines entire galaxies, unleashing energy equivalent to a quintillion nuclear bombs. What makes these events especially terrifying? Their predictability. Because all Type Ia supernova occur at nearly identical masses, they burn with the same apocalyptic brightness, a trait that makes them cosmic measuring sticks for astronomers. But that same predictability is also a death sentence for any world caught nearby. Earth wouldn't need to be right next to one to face annihilation. A zombie star detonating within just a few thousand light-years would bathe our planet in lethal X-rays and gamma rays, obliterating the ozone layer and triggering an extinction-level event. The radiation would scour the surface, mutating DNA and collapsing ecosystems in a matter of weeks. And here's the cruel twist: we might not even see the star responsible until it was too late. The blinding flash of the supernova would reach us at the same time as the deadly radiation. No time to flee, no time to prepare. History hints at how close we've already come. In 2006, astronomers observed a white dwarf in the Milky Way slurping material from a companion at an alarming rate. It's not a question of if another star will turn, but when. The universe is littered with these ticking time bombs, each one a reminder that even the dead can rise again with a hunger capable of ending worlds. Right now, as you sit there watching this, an invisible hurricane is raging through you at 500,000 meters per second, a storm made entirely of dark matter. Not rain or wind, but particles so elusive they pass through your body like ghosts, leaving no trace behind. These aren't just theoretical specks, they're the backbone of the universe, outnumbering normal matter 5-1. And one of their violent currents is slicing through our solar system as we speak, dragging entire galaxies in its wake. This cosmic tempest has a name, S1, the remnants of a dwarf galaxy torn apart by the Milky Way billions of years ago. Its debris now forms a river of dark matter stretching across the sky, a current moving so fast it defies imagination. If you could see it, the sight would be terrifying, a swirling vortex of invisible mass distorting the very fabric of space as it funnels through us. Every second, millions of these particles pierce your skin, your bones, even the atoms of your phone without a single collision. The real horror isn't just their invisibility, it's our helplessness. Modern detectors, built to catch the faintest whisper of dark matter, stand utterly silent in the face of this storm. The problem: these particles might not interact with ordinary matter at all. Picture tossing a net into a hurricane only to watch the wind slip straight through the holes. That's the frustration physicists face. Even as this invisible tsunami floods Earth, our tools can't measure its force, its direction, or its danger. Some theories suggest these particles could be weakly interacting massive particles with just enough mass to bend spacetime but not enough to leave fingerprints. Others propose actions, particles so lightweight they dance between dimensions. Whatever they are, their behavior is alien. They don't reflect light, emit radiation, or crash into atomic nuclei. They simply are, threading through our world like shadows through a locked door. Here's what keeps scientists awake at night: dark matter isn't passive. Its gravitational pull dictates the fate of galaxies, and its hurricanes could rewrite star maps overnight. If a denser current passed through us, its gravity might subtly warp planetary orbits, nudge asteroids toward Earth, or in a worst-case scenario, tug the sun off course over millennia. We'd have no warning until the stars themselves began to drift. The universe doesn't care that we're blind to its darkest forces. It moves on scales we're only beginning to fathom, where storms rage silently and particles flow like rivers through our veins. This isn't science fiction, it's happening now, and somewhere in the chaos, the next great cosmic tempest is already gathering, invisible, unstoppable, and utterly indifferent to the fragile world in its path. Quasars are the universe's ultimate celestial flamethrowers, supermassive black holes turned up to 11, spearing the cosmos with jets of plasma so intense they could erase entire solar systems in a blink. These aren't just distant specks of light, they're the brightest, most violent objects in existence, capable of outshining 1,000 galaxies combined while firing particle beams longer than the Milky Way's diameter. At their cores, black holes weighing billions of suns churn like hungry engines, swallowing entire stars and belching out energy that defies comprehension. What makes quasars truly terrifying is the sheer scale of their destruction. Those elegant jets you see in Hubble images, streaming out in near-perfect lines for hundreds of thousands of light-years, aren't just beautiful. They're death rays. The plasma inside them moves at nearly the speed of light, heated to millions of degrees and crackling with enough radiation to strip a planet's atmosphere clean off from clear across the universe. If Earth were to wander into the crosshairs of one of these beams, even from billions of light-years away, the effect would be apocalyptic. The jet's high-energy particles would ionize our upper atmosphere, shredding the ozone layer and exposing every living thing to lethal doses of cosmic radiation. Crops would wither, ecosystems would collapse, and the sky itself would glow with eerie auroras as our protective shield burned away. And here's the chilling part: quasars aren't relics of the past. While they were more common in the early universe, they still exist today, lurking in the hearts of distant galaxies. The jet from Quasar 3C273, for instance, stretches over 1,000,000 light-years, a searing lance of energy that could sterilize any world in its path. Even more unsettling, we're seeing these events as they were, not as they are. The light from quasars takes so long to reach us that by the time we detect them, their beams may have already swept through untold numbers of star systems, leaving behind nothing but scorched ruins. The universe doesn't need malice to be deadly. It simply obeys its own brutal physics, spawning engines of destruction so vast they dwarf human imagination. Quasars are a reminder, in the grand scheme of things, we're not just small, we're temporary, and somewhere out there, a jet of pure annihilation could already be slicing through the dark, aimed at nothing and everything all at once. The silence is the most terrifying part. After decades of scanning the cosmos with radio telescopes, listening for whispers of alien civilizations, we've heard nothing. Not a single confirmed signal, no distant broadcast, no cosmic hellos, just an endless, uncaring quiet. This eerie absence has a name, the Fermi paradox. If the universe is so vast, so ancient, with billions of habitable planets, where is everybody? The answers scientists have proposed range from the bleak to the utterly horrifying. One of the most chilling explanations is the dark forest theory. Imagine the universe as a vast, pitch-black woodland, where every civilization is a hunter hiding among the trees. They stay silent, not out of loneliness, but out of survival, because in this forest the first rule is simple. If you make a sound, something far more advanced and far more dangerous will find you. And it will eliminate you before you become a threat. Think about it. Any civilization that announces its presence risks drawing the attention of predators. Maybe they're ancient, paranoid empires that sterilize young species out of caution. Or perhaps they're machines left behind by long-dead creators, programmed to snuff out competition before it can evolve. In this scenario, the universe isn't empty, it's crowded, but everyone is holding their breath, praying not to be noticed, and then there's the great filter. This grim idea suggests that somewhere between a planet's birth and interstellar civilization, there's a near-impossible hurdle that wipes out nearly all life. It could be behind us, some rare fluke that let Earth survive when others didn't. But what if it's ahead, a fate so inevitable, so lethal, that no civilization ever survives long enough to colonize the stars? Nuclear war, runaway AI, bioengineered plagues, the possibilities are as endless as they are terrifying. The silence isn't just mysterious, it's a warning. Either we're alone, which is horrifying in its own way, or we're not, and whatever's out there has reasons to stay hidden. The universe might not be a place for explorers. It might be a battlefield where the only rule is stay quiet or die. Galactic cannibalism isn't science fiction, it's happening right now in our cosmic backyard. The Milky Way, our seemingly serene spiral home, is actually a predator slowly tearing apart and consuming a smaller galaxy in real time. The Canis Major Dwarf Galaxy, once its own distinct collection of stars, is now being stretched into a monstrous stellar stream, its stars ripped away by our galaxy's relentless gravity. Picture this, a river of stolen stars swirling around the Milky Way like cosmic spaghetti, pulled from their original home over billions of years. These aren't just random specks of light, they're the remnants of a massacre, a galaxy being digested bite by bite. The process is so violent that the Canis Major Dwarf is now little more than a shredded ribbon of stars, most of its structure already absorbed into our own. What's truly chilling is the inevitability of it all. Gravity doesn't negotiate, it doesn't stop, and the Milky Way isn't done. This same fate awaits the Large and Small Magellanic Clouds, the two brightest satellite galaxies visible from Earth. They're next in line for destruction, already showing signs of distortion as our galaxy's tidal forces begin their work. But here's the real horror: history repeats itself. The Milky Way isn't just the hunter, it's also prey. In 4 to 5 billion years, our galaxy will collide with the Andromeda Galaxy, triggering a brutal dance of destruction. Stars won't crash, they're too far apart, but the gravitational chaos will fling suns into wild new orbits, rip spiral arms apart, and likely merge the two galaxies into one monstrous elliptical blob. The aftermath, a cosmic graveyard. The night sky as we know it will vanish. The familiar band of the Milky Way will be gone, replaced by a shapeless haze of scattered stars. Any civilization still around to witness it will look up and see an entirely alien sky. Galactic cannibalism isn't just some distant spectacle, it's a reminder that even galaxies have lifespans. They're born, they feed, and one day they too are consumed. The universe doesn't play favorites, it feasts on everything. Beneath the bizarre, crystalline crust of a neutron star, pressures build to impossible extremes until suddenly, the entire surface fractures in a catastrophic starquake. These aren't like earthquakes on our planet. When a neutron star's crust, a material 100 trillion times stronger than steel, finally snaps, the energy released is incomprehensible. In a tenth of a second, it can unleash more power than our sun emits in 150,000 years. The numbers defy belief. A single starquake might hit with the force of 1 billion simultaneous nuclear detonations, shaking the very fabric of spacetime itself. The physics behind these cosmic tremors is just as terrifying as their scale. Picture a spinning neutron star, its surface as smooth as an atomic mirror under unimaginable gravity. But as it rotates, the crust warps under magnetic stresses more intense than anything in our galaxy. Fields so powerful they could strip the electrons from your atoms from 1,000 miles away. When the strain becomes too much, the crust shatters like glass, rebounding in violent oscillations that ripple outward at relativistic speeds. The recoil sends tsunamis of magnetized plasma racing across the surface, superheated to millions of degrees and glowing with lethal X-rays. We've actually witnessed these events. In 2004, NASA Rossi X-ray timing explorer caught a starquake on a magnetar, an especially magnetic neutron star 50,000 light-years away. The blast wave lit up satellites like a cosmic flashbulb, saturating their detectors despite the immense distance. If one occurred within even 20 light-years of Earth, the radiation would fry our atmosphere, triggering a mass extinction. But the true horror lies deeper. Some starquakes don't just crack the surface, they rearrange the star's entire magnetic field in an instant. Imagine snapping a rubber band stretched to its limit, but instead of a harmless twang, the recoil rewrites the laws of physics around it. The resulting magnetic reconnection can fire off bursts of gamma rays powerful enough to sterilize whole sectors of a galaxy. And here's the most unsettling part: we can't predict them. Neutron stars don't give warning tremors. One moment they're silent, the next they're unleashing energies that dwarf supernovae, all without a sound in the vacuum of space. The universe doesn't care if we're watching, it doesn't care if we're ready. It simply cracks its knuckles and entire star systems shudder in the dark. Imagine floating through space, expecting galaxies and stars to stretch endlessly in every direction only to find nothing. Not just darkness, but an impossible, yawning emptiness the size of 330 million light-years. This is the Boötes Void, one of the largest and most perplexing structures in the observable universe, a cosmic desert so vast it defies everything we know about how the universe should look. Most voids in space are predictable, small gaps between galaxy clusters, but Boötes is different. It's a staggering absence, a hole punched through the fabric of the cosmos where galaxies should be thriving. Instead, it holds only a handful where there should be thousands. To put its scale into perspective, if the Milky Way were placed at its center, humanity wouldn't have discovered another galaxy until the 1960s. That's how empty it is. Theories about how this void formed range from the unsettling to the downright eerie. One possibility involves something called cosmic inflation, where the early universe expanded so rapidly that it left behind bubbles of emptiness. Another suggests that dark energy, the mysterious force accelerating the universe's expansion, might be actively clearing out regions like Boötes, pushing galaxies apart faster than gravity can pull them together. But the most chilling idea that this void isn't empty at all. Instead, it might be packed with dark matter so dense it warps space-time itself, bending light around it and rendering anything inside invisible to our telescopes. Here's what haunts astronomers the most. Voids like Boötes might not be rare anomalies. They could be symptoms of a universe far stranger than we thought. Recent simulations hint at the existence of even larger voids, regions so vast they make Boötes look like a pothole. If true, the cosmos might be more whole than cheese, a Swiss cheese with gaps so enormous they distort our understanding of reality itself. The Boötes void isn't just empty space, it's a cosmic warning, a reminder that for all our mapping and measuring, the universe still holds absences so profound they swallow logic whole. And somewhere beyond the edge of our sight, another void might be growing silent, invisible, and hungry for light. The sun isn't just a warm, comforting light in our sky, it's a sleeping giant capable of unleashing hellfire with zero warning. Solar superflares are the ultimate proof. These aren't your average sunspots or solar flares. They're catastrophic explosions of magnetic energy so powerful they can punch through Earth's magnetic field like tissue paper. And we know they're real because one already hit us. In 1859, the Carrington event, named after astronomer Richard Carrington, who witnessed its initial flash, unleashed a geomagnetic storm so intense it set telegraph stations on fire. Sparks leaped from machines, operators received electric shocks, and auroras lit up the sky as far south as Cuba. That was over a century before modern electronics existed. If it happened today, civilization would grind to a halt within seconds. Imagine this, a wave of charged particles slams into Earth's atmosphere, inducing currents so strong they overload power grids like a surge frying your laptop, except this surge is continental in scale. Transformers, the backbone of our electrical infrastructure, would explode in showers of sparks, plunging cities into darkness, satellites fried, GPS gone, communication networks silent, the simulations are horrifying. A single EMP-like pulse from a solar superflare could knock out emergency services, disrupt water supplies, and collapse financial systems all within minutes. Food would rot without refrigeration, hospitals would lose power, planes might fall from the sky as navigation systems fail, and here's the most unsettling part: we're overdue. The Carrington event was strong, but geological records show even larger storms have struck Earth in the past. Ice cores reveal spikes in radioactive isotopes from events 12,000 years ago that make 1859 look like a minor spark. Modern estimates suggest a Carrington-level storm has about a 12% chance of hitting us in the next decade. That's not a distant threat, it's a ticking time bomb. The sun doesn't care about our technology. It doesn't care about our fragile networks. It simply follows the laws of physics, occasionally reminding us that our dominance on this planet is an illusion. A single outburst and the digital age could end in a flash of light back to the Dark Ages with no way to recover. The next superflare isn't a question of if. It's a question of when, and when it comes, we'll have roughly 12 hours from the first flash to the chaos that follows. 12 hours to prepare for the storm that could reset civilization. Dark energy isn't just expanding the universe, it might be priming it for the most violent end imaginable. The Big Rip isn't some distant cosmic whimper. It's an existential shredding machine, a fate so brutal that even black holes wouldn't survive. Picture this, an invisible force growing stronger every second, silently stretching the fabric of reality until it snaps. Not in billions of years, not in some far-flung galaxy, everywhere, all at once, starting with the largest structures and ending with the very atoms that make you. First, galaxies would be torn from each other, their gravitational bonds no match for dark energy's increasing grip. Next, stars within those galaxies would drift apart like embers from a dying fire. Then planets would be ripped from their orbits, their cores unraveling as the force penetrates their crusts. But the true horror comes last when the stretching reaches down to the subatomic level. Electrons would be torn from their atoms, nuclei would disintegrate, even quarks, the fundamental building blocks of matter, would be pulled apart in a final, silent scream. The universe wouldn't just end, it would be erased at the quantum level, leaving behind nothing but an endless, featureless void where time and space no longer have meaning. The math behind this scenario is what makes it so plausible. Normally, gravity and dark energy are locked in a delicate tug of war, but if dark energy's strength increases over time, a property called phantom energy, that balance shatters. Current observations can't rule this out. In fact, some measurements of distant supernovae suggest dark energy might already be doing exactly that, its influence growing subtly but inexorably with each passing eon. Here's the most unsettling part, the timeline. If the Big Rip is real, we might have less time than we think. Earlier estimates suggested trillions of years, but newer models accounting for phantom energy's acceleration hint it could happen in as little as 22 billion years, a blink in cosmic terms. And when it starts, the end would be mercifully quick. The final rip would propagate at the speed of light, giving no warning before atoms themselves come undone. The universe doesn't owe us permanence, it doesn't promise stability, and lurking in every measurement of distant galaxies is the terrifying possibility that reality itself is on borrowed time, that one day, without fanfare or flair, everything we know will be pulled apart in the ultimate cosmic unraveling. Dark energy might not just be expanding space, it could be sharpening the scissors. Some stars don't just drift through the cosmos, they're catapulted across the galaxy at speeds that defy reason, screaming through space at 2 million miles per hour. These aren't gentle wanderers, they're hypervelocity stars, celestial bullets fired from the most powerful cosmic gun imaginable, the supermassive black hole at the heart of our galaxy. Picture a binary star system, two suns locked in a graceful orbital dance, drifting too close to the black hole's event horizon. The unimaginable gravity tears one star away, slingshotting it into the void at a fraction of light speed while its doomed companion spirals into oblivion. The ejected star doesn't just escape the black hole's grasp. It becomes a runaway, hurtling through the Milky Way so fast it could cross the distance from Earth to the Moon in under 7 minutes. The energy behind this expulsion is staggering. We're talking about forces so violent they could fling a star clear out of the galaxy entirely, sending it on a one-way trip into the intergalactic abyss. The trajectories of these stars read like cosmic crime scenes. Astronomers have traced some back to the galactic center, where Sagittarius A, our supermassive black hole, sits like a monstrous pitcher hurling fastballs into the dark. Others, like the infamous star known as S5-HVS1, are already halfway to intergalactic space, moving so fast they'll never be bound by the Milky Way's gravity again. Here's what makes them truly terrifying. Hypervelocity stars don't travel alone. They drag their planetary systems with them, if any survived the ejection. Imagine a world orbiting one of these exiled suns, its surface scoured by relentless stellar winds as it barrels through interstellar gas clouds at unfathomable speeds. Any atmosphere would be stripped away, oceans would boil into space, and yet, against all odds, life might cling on in the shadows, utterly unaware that its sun is a fugitive from the heart of the galaxy. Even more unsettling, these stellar bullets aren't rare. Scientists estimate thousands are streaking through the Milky Way right now, silent, invisible to the naked eye, but carrying enough kinetic energy to obliterate anything in their path. A direct hit from one might be unlikely, but the sheer chaos they represent is a reminder. The universe doesn't just create, it also destroys, flinging its creations into the void with forces beyond comprehension. We think of stars as fixed points of light, eternal and unchanging, but hypervelocity stars shatter that illusion. They're proof that even the most massive objects in existence can become projectiles in an instant, launched into the dark by a universe that plays by rules we're only beginning to understand. Picture Earth from space, not serene and blue, but wrapped in a swirling noose of shattered metal, dead satellites, and razor-sharp debris moving faster than bullets. This isn't science fiction. It's Kessler syndrome, a catastrophic chain reaction that could slam the door on space exploration for centuries. Here's how it happens. One collision creates hundreds of fragments, each hitting another satellite, creating thousands more until low Earth orbit becomes an impenetrable minefield. The math is terrifying. A single bolt traveling at 17,000 miles per hour packs the kinetic energy of a grenade. Now multiply that by millions. In 2009, a defunct Russian satellite collided with an active American one, instantly spawning over 2,000 trackable fragments, each capable of destroying another spacecraft. But the real nightmare begins when the cascade becomes unstoppable. Every new collision would exponentially increase the debris field, creating a lethal halo around our planet so dense that rockets couldn't safely pass through. And we're already past the tipping point. Current estimates suggest there are over 130 million pieces of space junk larger than a millimeter orbiting Earth right now, everything from flecks of paint to entire abandoned rocket stages. The International Space Station regularly maneuvers to avoid these hypervelocity projectiles, but with each near miss, the odds worsen. Here's the chilling reality: Kessler syndrome isn't just a distant threat. Simulations show that even if all space launches stopped today, existing debris would continue colliding, potentially making low Earth orbit unusable within decades. Suddenly, satellite communications fail, GPS navigation vanishes, weather forecasting reverts to 1950s technology, and humanity, we'd be trapped planetside, watching helplessly as our own trash turns the sky into a barrier we can't cross. The most haunting part, unlike natural disasters, this one is entirely man-made. Every discarded rocket stage, every lost wrench, every dead satellite we've abandoned up there is a ticking time bomb, and we're the ones who armed them. The universe gave us the stars, and we might just box ourselves in before we ever truly reach them. Imagine a cosmic lighthouse, except instead of light, it blasts out magnetic fields so intense they could scramble every hard drive on Earth from 50,000 light-years away. Meet the magnetar, a neutron star on steroids, spinning with a magnetic field 1,000 trillion times stronger than our planet's. At their poles, these monsters generate forces so powerful they literally twist the fabric of spacetime itself, bending light into eerie halos and warping the vacuum of space into funhouse mirrors. One of these beasts, named SGR 18020, once unleashed a burst of energy so violent it briefly outshone the entire Milky Way despite being halfway across the galaxy. The December 2004 flare lasted just 0.2 of a second, but in that blink of cosmic time, it released more X-rays than our Sun will emit in 250,000 years. If you'd been standing on the moon during that burst, the radiation would have fried you instantly. Earth's atmosphere shielded us that time, but here's the nightmare scenario. If a magnetar erupted within just 10 light-years, its magnetic pulse would induce currents in power grids strong enough to melt transformers across continents. Credit cards wiped, hard drives, blank slates. The electromagnetic shockwave would essentially drag humanity back to the pre-digital age overnight. The physics behind these eruptions is even wilder. Magnetars aren't just dense, their crusts are under such unimaginable stress that when they crack, the resulting starquakes launch tsunamis of magnetized plasma along their field lines. These particles spiral outward at nearly light speed, vibrating the star's magnetic field like a plucked guitar string. The oscillations then ripple through space, stretching and compressing spacetime itself in their wake. If you could see these distortions, they'd look like heat waves warping the stars behind the magnetar, a gravitational lensing effect so extreme it'd make Einstein's head spin. What makes magnetars truly unsettling isn't just their power, it's their unpredictability. unlike pulsars with steady rotations, magnetas lurch and stall like cosmic drunks, their surfaces heaving under magnetic pressures we can't fully model. Some, like the infamous Darth Vader star in the constellation Sagittarius, go dormant for decades before suddenly erupting without warning. And here's the existential kicker: our galaxy likely holds millions of these sleeping giants. Most are too far away to threaten us today, but the universe is old. Given enough time, a magneta could awaken anywhere at any moment and rewrite the rules of physics in its neighborhood. No warning, no mercy, just a flicker in the data logs as spacetime itself curls under the weight of a magnetic field we'll never truly comprehend. The universe doesn't need black holes to be terrifying. Sometimes all it takes is a spinning corpse with a magnetic personality. On the night of August 15, 1977, a radio telescope in Ohio picked up something that should have been impossible. A signal so powerful, so unnatural, it sent chills down the spines of the scientists who discovered it. The burst of noise lasted just 72 seconds, but in that time, it screamed across the cosmos at a frequency that defied all known cosmic phenomena. When astronomer Jerry Amon first saw the data printout, he circled the signal's alphanumeric code in red ink and wrote a single word beside it: "Wow." That scrawled note gave the mystery its name, and to this day, the WOW signal remains one of the most unsettling enigmas in the search for extraterrestrial intelligence. What made this signal so terrifying? First, its intensity. The blast of radio waves was 30 times stronger than the background noise of deep space, a spike so abrupt it couldn't have come from any natural cosmic event. Second, its frequency, exactly 1420 MHz, a narrowband wavelength that just so happens to be one of the most efficient for interstellar communication, right in the quiet zone where cosmic interference is minimal. It was as if someone had deliberately tuned a cosmic transmitter to the clearest possible channel. Then there's the origin. The signal came from the direction of the constellation Sagittarius, near a star system called Chi Sagittarii, a region with no known pulsars, quasars, or other celestial objects capable of producing such a focused radio burst. Even stranger, the signal never repeated. Despite decades of follow-up observations, not a single blip has ever been detected from that location again. That's the part that haunts researchers. If this wasn't a natural phenomenon and it wasn't human-made, then who or what was broadcasting? Theories range from the plausible to the chilling. Some argue it was a passing comet reflecting solar radiation, except comets don't emit narrowband signals. Others suggest military satellite interference, but no known technology in 1977 could have produced a burst that powerful. Then there's the darkest possibility, an intentional one-time transmission from an advanced civilization, a cosmic hello that we just happened to catch. Or something far more ominous. Listen closely to the recording, that eerie, wavering tone buried in static. It's not the dramatic beep of a Hollywood UFO. It's subtler, more deliberate, a whisper from the void that leaves us with more questions than answers. The WOW signal is a reminder that the universe might be shouting at us in a language we don't yet understand. And one day, when we finally decode it, the message might not be one we want to hear. Galactic cosmic rays sound like something from a sci-fi weapon, but they're horrifyingly real, a relentless barrage of high-energy particles fired at near light speed from supernovae, black holes, and other cosmic calamities. Unlike the gentle sunlight warming your skin, these atomic bullets pack enough punch to pierce through spacecraft hulls, spacesuits, and even human cells with ease. What's worse, there's no escaping them in deep space. Astronauts describe sudden, inexplicable flashes of light behind their closed eyelids, phantom brain zaps, caused by these particles tearing through their visual cortex like microscopic lightning bolts. The damage doesn't stop at eerie light shows. When a cosmic ray slams into DNA, it doesn't just nick the double helix, it shatters it. Picture a bullet ripping through a delicate spiderweb, leaving jagged, irreparable breaks in its wake. Laboratory simulations show single cosmic ray particles can snap both strands of DNA at once, triggering mutations that repair systems struggle to fix. Over time, this adds up. Studies on astronauts reveal higher rates of cataracts, weakened immune systems, and even signs of accelerated brain aging. Prolonged exposure could mean memory loss, cognitive decline, or worse, radiation-induced cancer lurking in every cell. Here's the chilling part. Earth's magnetic field shields us from the worst of this onslaught. But on Mars, where the atmosphere is thin and there's no global magnetic shield, cosmic rays rain down unimpeded. Future colonists might not just face a harsh environment, they could be signing up for a slow, invisible poisoning. Even on the International Space Station, astronauts receive about 10 times the radiation dose of someone on Earth, and a trip to Mars could expose them to levels equivalent to a full-body CT scan every single day. The most unsettling discovery: cosmic rays aren't random. They follow supernova highways, magnetic tunnels carved by exploding stars, funneling these particles across the galaxy like cosmic shrapnel. Some originate from regions we can't even see, their sources hidden behind interstellar dust. And if a nearby star went supernova, the resulting cosmic ray storm could bathe our solar system in lethal radiation for centuries, no shelter deep enough to hide. Space doesn't just kill you with cold, vacuum, or asteroids. It bombards you silently, relentlessly, rewriting your very biology one atomic bullet at a time. And as we reach farther into the cosmos, we're learning the hard way. The universe isn't just empty, it's armed. The universe isn't just expanding, it's being pulled. Hundreds of galaxy clusters, each containing trillions of stars, are streaming toward something we can't see, something beyond the edge of our observable universe. Astronomers call this phenomenon the dark flow, and it defies everything we know about cosmic motion. Imagine throwing a handful of leaves into a river, only to watch them all inexplicably drift in the same direction against the current. That's the eerie reality of our cosmos. A mysterious force is dragging entire galaxies toward an unseen horizon, like moths to a flame we'll never witness. The evidence comes from redshift maps, color-coded charts of the universe's expansion, where clusters clearly move not just apart from each other, but together toward a single point in space. These aren't small deviations. We're talking about velocities of nearly 2 million miles per hour, far faster than the gentle drift expected from the Big Bang's afterglow. The most chilling part: whatever's causing this motion lies outside our cosmic horizon, beyond the 14 billion light-year bubble of space we can observe. It's as if the universe is haunted by a gravitational ghost, its hands tugging at the fabric of reality from a place we'll never reach. The leading theory is as unsettling as the observation itself. The dark flow might be the fingerprint of a supermassive structure lurking in the unobservable universe, a cosmic neighbor so enormous its gravity distorts our local space-time like a hidden magnet bending iron filings. Some speculate it could be a colossal concentration of dark matter, a realm where galaxies pack together tighter than anything we've ever seen. Others dare to suggest something even stranger: a remnant of the pre-Big Bang universe, a scar from a time before time, whose gravity still echoes into our existence. But here's what keeps cosmologists awake at night. If the dark flow is real, it challenges the cornerstone of modern astronomy, the cosmological principle which states the universe should look roughly the same in all directions. Instead, we're faced with the unnerving possibility that our cosmos isn't uniform at all. It might be lopsided, unbalanced, with unseen asymmetries stretching into infinity. And whatever's out there, whatever's pulling, it's rewriting the rules of the game on scales we can't comprehend. The dark flow isn't just a curiosity. It's a cosmic wake-up call. For all our telescopes and theories, we're still peering through a keyhole, glimpsing fragments of a reality far stranger and far more unsettling than we ever imagined. The universe isn't just expanding, it's fleeing, and whatever it's running from might be worse than we dare to guess. Rogue planets are the forgotten orphans of the cosmos, dark, frozen worlds cast adrift from their parent stars, wandering the interstellar void in perpetual exile. Astronomers estimate there could be billions of these nomads lurking unseen in our galaxy alone, untethered from any solar system, invisible to telescopes unless they pass directly in front of distant stars. Some are gas giants ejected during the chaotic ballet of planetary formation. Others are Earth-sized ice balls, their surfaces frozen to temperatures near absolute zero, where even the atmosphere has collapsed into a layer of glacial snow. The thought of one drifting into our solar system undetected is where the horror truly begins. Unlike asteroids or comets, rogue planets emit almost no heat, no infrared signature to betray their approach. Traveling at typical interstellar speeds, one could slip past the outer planets before we'd even notice its gravity subtly tugging at their orbits. By the time our telescopes caught a glint of sunlight reflecting off its frozen surface, it might already be closer than Neptune. Imagine the chaos. A planet-sized intruder barreling through the Kuiper belt would send a shockwave of debris inward, flinging icy bodies toward Earth like cosmic shrapnel. Its gravity could destabilize asteroids, redirecting them onto collision courses. Even if it didn't smash into anything directly, the gravitational ripples might be enough to nudge Earth's orbit, shifting our climate into an ice age or roasting us closer to the sun over millennia. The darkest twist, some rogue planets might not be entirely dead. Tidal forces from their ejection could have heated their cores, creating subsurface oceans beneath miles of ice, a hidden habitat where life, if it ever existed, might still cling on in the darkness. If one of these frozen worlds carried dormant extremophiles into our system, the consequences could range from scientific marvel to existential threat. We've already found hints of their presence. In 2020, astronomers detected a rogue planet roughly the size of Earth floating freely near the Milky Way's core. Its surface temperature, a bone-chilling negative 280 degrees Fahrenheit, and that's just one we happen to spot. The galaxy could be teeming with them, silent, invisible, and utterly indifferent to the delicate balance of our solar system. Space isn't just empty, it's a minefield of forgotten worlds, any one of which could rewrite our fate without warning. The universe doesn't announce its dangers. Sometimes they just drift into the light. Beneath the smooth canvas of space and time we perceive lies a nightmare of pure chaos, a frothing, seething underworld where reality itself boils and glitches at scales smaller than an atom. This is quantum foam, the turbulent foundation of existence, where the very fabric of spacetime isn't just bent or warped, it's shattered into an infinite frenzy of virtual particles popping in and out of existence like bubbles in a cosmic soda. The universe we know, with its orderly planets, predictable orbits, and stable laws, is just a thin veneer stretched over this relentless storm. Zoom in far enough, and the smooth geometry of Einstein's relativity collapses into fractal madness. Space becomes discontinuous, riddled with microscopic black holes and wormholes that flicker into being for fractions of a second before vanishing again. Time stutters, skipping forward and backward in fits of quantum uncertainty. Even the vacuum of empty space isn't empty at all. It's a maelstrom of energy where particle-antiparticle pairs materialize from nothingness in a ceaseless dance of creation and annihilation. The math behind this is terrifyingly precise. Heisenberg's uncertainty principle guarantees that at these scales, energy can borrow from the future to spawn particles, just long enough to obey quantum rules before vanishing back into the void. Imagine running your hand along a tabletop, only to discover its surface is actually a swarm of angry bees. That's the horror of quantum foam. At Planck length, a scale so small it makes atoms look like planets, space and time lose all meaning. Distances fluctuate wildly, causality breaks down, an electron traveling from point A to point B might not follow a straight path because straight no longer exists. Instead, it tunnels through an infinite number of alternate routes, surfing the foam's chaotic waves like a ship lost in a hurricane, the most unsettling part. This isn't theoretical. We've seen glimpses of quantum foam's fury in the lab. When scientists examine the spin of distant quasars, their light sometimes arrives with tiny, unexplained jitters, as if it's been buffeted by microscopic space-time bubbles along its billion-year journey. Other experiments suggest that if you could measure position with Planck-scale precision, the very act of observation would inject enough energy to create quantum foam, like poking a still pond and watching it explode into froth. What does this mean for reality? On human scales, the chaos averages out, leaving the illusion of stability. But venture too deep, say, near a black hole singularity, and quantum foam might shred space-time itself. Wormholes could form and collapse in the tumult, bridging distant points in the universe or other universes entirely. Some theories even suggest our entire cosmos is just one stable bubble in an endless sea of foam, a single sane note in a cacophony of failed realities. So the next time you gaze up at the tranquil night sky, remember this: the stillness is a lie. Beneath it all, the universe is screaming. Far beyond the orbits of Neptune and Pluto, lurking in the frigid darkness at the edge of our solar system, lies a frozen graveyard of ancient debris, the Oort cloud. Picture a vast spherical shell of icy boulders and dormant comets, stretching nearly a light year into space. This is no orderly asteroid belt. It's a chaotic swarm of primordial leftovers from the birth of our solar system, held together by nothing more than the sun's faint gravitational whisper. And within this frozen labyrinth, countless objects are waiting for just the slightest nudge to send them hurtling toward Earth at catastrophic speeds. The numbers alone are staggering. Astronomers estimate the Oort cloud could contain trillions of icy bodies, some as large as mountains. Most drift silently in the void, but when a passing star, galactic tide, or even the tug of the Milky Way itself disturbs their delicate balance, these sleepers awaken. Like a cue ball striking a rack of billiard balls, one small perturbation can send comets screaming inward, their trajectories amplified by gravity into deadly straight shots toward the inner solar system. By the time we spot them, they're often already closer than you'd think, with terrifyingly little time to react. Consider the case of Comet Hale-Bopp, one of the brightest comets of the 20th century. When it was discovered in 1995, it was already barreling toward us from the Oort cloud at nearly 100,000 miles per hour. Had its path been slightly different, we might have had mere months, not years, to prepare for impact, and Hale-Bopp was a relative slowpoke compared to some. Long-period comets, those flung from the Oort cloud's depths, can reach speeds over 200,000 miles per hour. At that velocity, even a modestly sized comet would strike with the force of thousands of nuclear bombs, triggering global firestorms, tsunamis, and a decade-long nuclear winter. The scariest part, we've barely scratched the surface of mapping this icy minefield. Current telescopes struggle to detect Oort cloud objects until they're well on their way, sometimes just months from swinging past the sun. That means the next dinosaur killer could already be en route, invisible against the blackness of space, cloaked by distance and the limitations of our technology. History offers chilling proof of what happens when these icy wanderers collide with Earth. 66 million years ago, a comet or asteroid just 6 miles wide, likely an Oort cloud refugee, slammed into the Yucatan Peninsula. The impact unleashed energy equivalent to 10 billion atomic bombs, vaporizing everything within hundreds of miles and filling the sky with enough debris to blot out the sun for years. 75% of all species, including the dinosaurs, were wiped out in the aftermath, and that wasn't an isolated event. Geological records show similar cataclysms every few dozen million years, a grim reminder that Earth exists in a cosmic shooting gallery. Here's the unsettling reality. The Oort cloud isn't just a distant curiosity. It's a loaded gun aimed at our planet, its trigger pulled by the random gravitational jostling of the galaxy. Each passing star, each ripple in the fabric of space, could be the nudge that sends another extinction-level comet our way. And unlike asteroids, which often follow predictable orbits, these icy intruders appear suddenly, streaking across the sky with little warning, a frozen messenger from the void carrying a message written in fire and ice. The universe doesn't announce its dangers. Sometimes they just emerge from the dark. Among all the possible ways the universe could end, none are as quietly sinister as the false vacuum collapse, a quantum doomsday scenario where reality itself gets rewritten in an instant. Imagine the laws of physics as dominoes carefully balanced in a stable formation. Now picture one domino wobbling just slightly until it tips and the entire structure comes crashing down in an unstoppable chain reaction. That's the essence of false vacuum decay. Our universe might not be in its most stable state, but instead sitting in a precarious, false equilibrium, a cosmic house of cards, silently waiting for the slightest nudge to collapse into a truer, deadlier form. The mechanics are as terrifying as they are elegant. Quantum fields dictate everything in existence: gravity, light, even matter itself. Right now, these fields exist in what physicists call a local minimum, a stable-ish valley in the landscape of possible realities. But somewhere beyond that valley, there might be a deeper, more stable state, a true vacuum. If a quantum fluctuation, no matter how tiny, pushes the field over the edge into that lower state, a bubble of true vacuum would form. Inside that bubble, the fundamental constants we rely on, the speed of light, the strength of gravity, even the behavior of atoms, would be rewritten from scratch. And the worst part, that bubble would expand in all directions at the speed of light, converting everything it touches into this alien new reality. Visualize it like an infection spreading across the cosmos. The moment the bubble forms, its border becomes an inescapable wave of annihilation. Planets, stars, galaxies, none of it matters. By the time the light from the collapse reaches us, the wave itself would already be here, meaning we'd have zero warning. One moment, the universe is as we know it. The next, every atom in your body, every law of chemistry, every force that binds matter together stops working the way it should. Life, as we understand it, would be impossible in this new reality. There'd be no pain, no explosion, no fire. Just an instant, silent erasure of the rules that make existence possible. Here's the most unsettling part. This isn't science fiction. The Higgs field, the same quantum field that gives particles their mass, might be sitting in a false vacuum right now. If it is, then all it would take is one random quantum event anywhere in the universe to trigger the cascade. Some theories suggest high-energy particle collisions could do it, though the odds are astronomically low. Others argue cosmic rays or black hole mergers might be the spark, but once it starts, there's no stopping it. The bubble would expand forever, rewriting physics as it goes, leaving behind a universe utterly unrecognizable. And here's the final, chilling thought. If this has already happened somewhere out there, we wouldn't know. The wave moves at light speed, so its arrival would be simultaneous with its visibility. The last thing any civilization would ever see is the sky turning wrong. The universe doesn't owe us stability. It doesn't promise permanence, and somewhere in the infinite dark, the dominoes might already be tipping. Black holes don't just crush matter, they might unravel the very fabric of reality itself. Imagine slipping past the event horizon, that invisible point of no return, where the laws of physics as we know them cease to exist. At first, you'd feel nothing. No sudden jolt, no dramatic pull, just the eerie sensation of time slowing down as the black hole's gravity warps the space around you. But then the horror begins. Your body starts stretching, your feet accelerating faster than your head, until you're no longer a person but a grotesque, elongated strand of atoms, spaghettification in its most literal, visceral form. Every molecule in your body would be pulled apart like taffy, your consciousness stretched across infinity as you dissolve into the abyss. But here's where it gets even stranger. According to quantum mechanics, information, the blueprint of what makes you, can never truly be destroyed. Yet Einstein's theory of relativity insists that whatever falls into a black hole is lost forever, crushed into a singularity where space and time break down. This contradiction is the black hole information paradox, a cosmic glitch that has physicists questioning whether reality itself has a fatal flaw. One terrifying resolution. You might be cloned. From the perspective of someone watching you fall in, your body would appear frozen at the event horizon, slowly fading into nothingness due to time dilation. But from your perspective, you'd already be torn apart inside. So where does your consciousness go? Some theories suggest black holes create a holographic copy of you on their surface, a ghostly imprint of your existence encoded in the event horizon's quantum fuzz. Others propose that you're split into two versions, one vaporized in a fiery burst of Hawking radiation, the other lost in the singularity's infinite darkness. The implications are mind-shattering. If black holes can duplicate or erase information, what does that mean for the nature of reality? Are we all just temporary patterns in a cosmic hard drive, flickering in and out of existence at the whim of unseen forces? The universe doesn't offer answers, only the silent horror of the paradox, a riddle written in the screams of every atom it consumes. Every star, every planet, every flicker of light in the cosmos is racing toward the same inevitable fate, not with a bang, but with a whimper so quiet it defies comprehension. This is the heat death of the universe, the ultimate victory of entropy over order, where the last embers of energy fade into an endless, uniform cold. Picture a candle burning down, its flame shrinking until nothing remains but wax and smoke. Now imagine that candle is the entire universe, and the wick has 14 billion years left to burn. The process is already underway. Stars are the universe's engines, converting mass into light and heat, but their fuel is finite. One by one, they'll exhaust their hydrogen, flare into red giants, and collapse into white dwarfs or black holes. Galaxies, stripped of their stellar nurseries, will darken like cities under a permanent blackout. Even black holes won't last forever. Through Hawking radiation, they'll slowly evaporate over trillions of years, their final moments marked by a faint pop of photons, the last whisper of structure in a dying cosmos. Time itself becomes meaningless in this frozen twilight, with no energy gradients left, no hot or cold, no high or low. Nothing can change, no chemical reactions, no motion, no thought. The universe will reach maximum entropy, a state of perfect equilibrium where every particle is evenly spaced, every temperature identical. It's the thermodynamic equivalent of a room where every air molecule sits perfectly still, never colliding, never stirring. Without difference, there can be no work, no life, no stories, just a static sea of sameness stretching into eternity. The most unsettling part, this isn't speculation. The laws of thermodynamics demand it. Energy disperses, systems wind down. The universe, for all its violence and beauty, is a clock ticking toward silence. Even now, as you watch this, the cosmic background radiation, the afterglow of the Big Bang, cools by a fraction of a degree each passing century. One day, it will match the temperature of empty space, and the last remnant of creation's fire will vanish. Close your eyes and imagine the final galaxy, its stars reduced to cinders, drifting alone in the void. Its last black hole evaporates in a puff of radiation. The universe, now trillions upon trillions of years old, is darker than a cave at the bottom of the ocean, colder than the deepest reaches of interstellar space. Emptier than a vacuum could ever be. This is how it ends, not with fire or ice, but with the slow, inevitable fade of all things. The cosmos doesn't mourn. It doesn't remember, it simply stops, and in that infinite stillness where time has no meaning and change is impossible, the universe achieves its final, terrible perfection, silence without end. From rogue black holes drifting unseen through the galaxy to the silent scream of vacuum decay rewriting reality itself, we've journeyed through 25 cosmic horrors that defy comprehension. Gamma ray bursts hotter than a billion suns, magnetars twisting spacetime with magnetic fury, zombie stars resurrected by stolen light, and the great Attractor's invisible pull dragging galaxies toward an unknown fate. The Oort clouds' icy bullets lurking at the edge of our solar system, dark matter hurricanes ripping through your body unseen, and quasars firing jets of annihilation across cosmic distances. The wow signal's cryptic whisper, the Boötes void's hunger for light, and the false vacuum's quantum time bomb ticking beneath the universe's surface. Starquakes shattering neutron stars, hypervelocity stars launched like galactic shrapnel, the dark flow's mysterious tug toward the unknowable, and the heat death's inevitable frozen silence. Kessler Syndrome's man-made prison of orbital debris, cosmic rays shredding DNA in deep space, and the black hole information paradox cloning your consciousness into oblivion. Galactic cannibalism devouring whole star systems, rogue planets drifting like frozen ghosts, and the quantum foam's chaotic underbelly where reality itself boils into madness. Each one a reminder the universe isn't just vast, it's vicious, a place where time, space, and physics conspire in ways that humble our fragile existence. So here's the question that lingers as the screen collapses into a final black hole swallowing light, hope, and certainty in its wake. In a cosmos so indifferent to life, so saturated with terrors beyond our control, is our fleeting existence a miracle or a cosmic accident waiting to be erased? The answer might terrify you more than anything we've covered today. If you dared to face these horrors with us, smash that like button, subscribe, and brace yourself because the universe isn't done with its nightmares yet.